Hello gang class, and welcome back to Sine Law. This is part 2 where we're actually going to get into some examples. So example 1 here, I have a triangle properly labeled. Make sure you copy it down because I want you to be able to follow along what I'm doing. In this example, we see that we don't know what angle B is. The problem is, if we're going to use Sine Law, we need to know what both angle and side of a matching pair. So if I want to use angle B, I need to use angle B and side B in order to use Sine Law. It doesn't work when you only have one. You need both. So you need B and B, or A and A, or C and C in order to figure out everything else. So our first step is to figure out what angle B is. And in order to do that, we need to remember that 180 degrees will equal all the angles of a triangle added up together. So if we take 180 and subtract angle A and angle C, we'll get angle B. Subtract 25, subtract 80, and that equals angle B. And you can use a calculator, but I'm quite confident that it's equal to 75. So then we get 75 degrees. So now that we know a set, so we know both angle and side B, we can use that ratio to solve any other side length. Let's solve side A first though. And because we're trying to figure out a side length, if we actually go look back in our notes, I'm going to go back here for a second. Because we're trying to find out another side length, but we know at least two angles, we use number 1 here. So I'm going to use A over sine A equals B over sine B. I'm going to go back to my example here. And I'm going to use green. So A over sine of A equals B over sine of capital B. So now I just need to fill in the unknowns and I can solve for A. So I know angle A is 25. I'm going to rewrite this now again back in blue. So I don't know A, but I know sine 25. Okay then, equals, we're going to get 50 over sine of B, which is 75. So you could go ahead and evaluate this with your calculator now. One thing I'm going to do first is I'm going to rewrite it. So it's going to be A. I'm going to multiply both sides by sine of 25 to eliminate this, because if I use yellow here, I can better sine of 25 times sine 25. I can eliminate this because I'm dividing it there. So really, I have A is equal to 50 over sine 75 times sine 25. Well, how does that look when we try to enter it into a calculator? Alright, so now I have my calculator open. I'm going to punch this in, so it needs to be 50 divided by, well, over sine of 75, so 75 sine, close that bracket, equals that. So that's what this part of the equation equals, and then I have to multiply it by sine of 25. So I'm going to put 25 sine equals, there we go. So A equals 21.876. I'm going to round it up to 21.88. So we got A equals 21.8 meters. All right, I'm going to use another slide to figure out side C. All right, and we're back with the same example. I just added in the side length for A. Now we can solve for side C. Of course, we're going to use angle C to find out side C. So in this case, we know 3 angles. That's okay. We just need to use C, and I'm going to use B again because it works out a little bit nicer. All right, so I'm going to use the formula. I'm trying to find C this time, so this is going to be sine of C equals B over sine of B. All right. So you see, we don't have to use a whole formula every single time. We're just going to use 2 parts of the sine law. All right. To solve for C is our unknown variable, but we know this is going to be sine of 80 this time, which equals 50 all over sine of 75. Again, you could just punch this into the calculator. I'm going to multiply both sides by sine of 80, so times sine of 80, then times sine of 80. Didn't really leave myself that much room. And what ends up happening is, if I multiply it, it cancels out the sine 80. And then my next line is nice and neat. I know exactly what C is going to be, because it's going to be 50 over sine of 75 times sine 80. So now that I have my calculator out, I'm just going to punch this in. So 50 divided by, I'm going to use a bracket, 75 sine, and that bracket equals that. So again, I figured out this part of the equation first. Now I'm going to multiply it by this. So times 80 sine, which equals, equals 50.977. I'm going to round it up to 50.98 meters. And that's the end of the first example. So for example 2, I just want you to find the missing angles, mostly because you know how to figure out the missing sides. You know not to use the Pythagorean theorem. You have to use the sine law if it's not a right angle triangle. If it is a right angle triangle, then you can. Alright, so let's find the missing angles. First, to make this a little bit simpler, I'm going to label the triangle A, B, and C, just so I can better conceptualize what's happening. The first angle that we should try to find, because we know the side length, should be angle B. So we're going to try and figure out angle B using the sine law. I'm going to go back to this slide, and this time we're not using slide 1, we're actually going to use slide 2, or formula 2. We're going to use formula 2, not formula 1 this time, because we know 2 side lengths, and now we need to solve for another angle. In this case, we're solving for angle B, and in order to do that, we're going to try and put the angle B at the top, so sine of B, because it's our unknown, and then we put the side length of B, which is always the opposite, so right there, equals sine of 25, which is our angle A, and the opposite is 16. So now I need to start solving this. A quick way to do this is to multiply both sides. We're going to try and isolate B. So we're going to times both sides by 37. What ends up happening is you're multiplying then dividing, so it cancels out, and then you get sine b on its own equals sine 25 over 16 times 37. Then you take it one more step, so you know that b is going to be on its own, and the only way you can do that is if you take both sides, sorry, I'll do this in green, both sides, take the sine inverse, and take this, take the sine inverse, and what happens is the sine inverse and sine cancel out, so then you get b isolated. So we know b is equal to sine inverse of sine 25 over 16 times 37. So we're going to pull out our calculator and figure this out. Now I have my calculator open. I'm just going to take this slowly. 25 sine. So we know what's on top of the brackets there. We're going to divide it by 16. Okay, so we get a big decimal. Then we're going to multiply it by 37, which gives us 0.977. And we're going to take the sine inverse of that. So I press sine inverse. And that's it right there, 77.769. I'm going to say it's, I'm going to round to the nearest 1, or nearest whole, so it would be 78. So in this case, b is equal to 78 degrees. Alright, I'm going to make another slide, and I'm going to show you how we get angle C now. Okay, so continuing on with example 2, we already figured out angle B, and what's exciting about this is we no longer need to use sine law to find the last angle. We can actually just use 180 and subtract the two known angles. So subtract 25, subtract 78, and then we get 77 degrees. You can use a calculator to verify, but that's the end of that. I'm not going to show you how to find that last side length because we've already done that in example 1.